Hello my dear students, today we'll speak about the electrolytic cell. Electrolytic cell, now we know that there is an electrolytic cell and a galvanic cell. We have studied the galvanic cell, which we transfer the chemical energy into electric energy. Now we'll speak about, or we will study the electrolytic cell, which transfers or converts the electric energy into chemical energy. So, an electric energy or electric outer external source that is provided to this electrolytic cell to make a non-spontaneous oxidation reduction reaction. Electromotive force of the electrolytic cell is negative, as the reaction of oxidation reduction which happens in the electrolytic cell is non-spontaneous. Here in galvanic cell, as we have said, as we have studied, that the electromotive force value is a positive value, as the oxidation reduction reaction that happen in galvanic cell is a spontaneous reaction. So what is the electrolytic cell? Here we see the electrolytic cell, a battery, an external source of electric current, the electrode which is connected to the positive pole of the battery is the anode, at which the oxidation process happen, and the electrode which is connected to the negative pole of the battery is the cathode, where the reduction process happen. There is an electrolyte here. Okay, electrons flow in the outer wire from the positive pole to the negative electrode, from the positive electrode to the negative electrode, from anode to cathode. Okay, and you have to memorize this. Anions in all types of cells, go to the anode, and cations go to the cathode. The anions, which is the negative ions, which are rich in electrons, go to the positive pole to neutralize their charges by losing electrons, and cations, the positive anions or the positive ions, go to the cathode. They have less amount of electrons, so they go to the cathode and neutralize their charge by accepting electrons, means reduction. So anions to go to the anode to be oxidized, and cations go to the cathode to be reduced. In all kinds of cells, anions go to the anode and cations go to the cathode. In this case, it is an electrolytic cell, so an external source of electric energy is converted into chemical energy during a non-spontaneous oxidation reduction reaction. So the two electrodes may be of one substance, like graphite or platinum, some inert substance. They do not share or participate in the chemical reaction or in the oxidation reduction reaction. If they are from different substances, like this silver or something like that, the anode, so the anode only participate or share in the oxidation reduction reaction. So what is the composition in detail? The composition of electrolytic cell: positive electrode connected to the positive pole of the battery, it is the anode here, and it is the positive electrode. Anions go to the positive electrode to be oxidized, leave excess electrons. Okay, another electrode is the electrode that is connected to the negative pole of the electric source and act as cathode. It is the negative pole, or connected to the negative pole, where cations go toward it. Cations, positive ions, go to the cathode, and reduced means accept electrons. So anions go to the anode to be oxidized, and cations go to the cathode to be reduced. So here, anions, electrons rich material particles, go to the anode, the positive electrode, as anions is a negative, has a negative charge, a negative charge, so they go to the anode, which is the positive electrode, to be oxidized by leaving electrons and neutralize their charge at the anode. Cations, positive ions, go to the cathode. They are poor material of electrons, poor substances of electrons, less electrons, so they move towards the cathode to neutralize their charges by reduction, by accepting electrons. Go to the cathode to accept electrons and to undergo reduction process. So what is electrolysis? Electrolysis is known as the moving of electric current in the electrolyte, and this electrolyte is decomposed into its initial or very simple substances. So the moving of electric current, passing of electric current through the electrolyte decomposes to simpler substances. So the process of chemical decomposition of the electrolyte due to the effect of passing of electric current in it is known as electrolysis. Electro means electric current, lysis means decomposes by electric current. So let's have some examples about this. Which of the following processes occurs at the cathode of the electrolytic cell? Lead to bromide melt. It is not an aqueous solution, it is a melt. But here we have to notice that what happens at the cathode. What happens at the cathode is cations, positive ions, go to be reduced by accepting electron. So this is not positive ions, it is wrong. This is not a positive ion, it is wrong. This is not a positive ion. Here, lead positive 2 reduced on the cathode to be lead 0 solid, and this is the correct answer. The correct answer here means cations go to the cathode, cations positive ions, and be reduced by 2 electrons to form lead 0 solid. Another example. Here the following equations represent reactions occurring during the electrolysis process. These are some equations, okay? What the problem want is, or what the question about is, which of the following choices represents the reaction occurring at the anode? The reaction occurring at the anode. The anode means anions oxidized. Anions means ions with negative charges. So this is not anions. This is not anions. Anions here for hydroxide. Okay, they are oxidized or reduced. They leave electrons, so they are oxidized. Okay, chlorine or chloride is a negative anion, so it go to the anode. Yes, sure. Oxidized or reduced, it is oxidized as it loses 2 electrons. So 2 is correct and 1 is correct. Here the choices A, 1 and 2, 1 and 3, 2 and 4, and 3 and 4. Here the correct choice is A. Let's speak about another example. Here, which of the following statements represent the movement of cations in the electrolytic solution? They move towards the cathode in the electrolytic solution and towards the anode in the galvanic cell. Or they move towards the anode in the electrolytic solution and towards the cathode in the galvanic cell. Or they move toward the cathode in both electrolytic and galvanic cell, or move towards the anode in both electrolytic and galvanic cell. Now we ask about cations go to the cathode in both cases, in galvanic cell and electrolytic cell. You have to memorize it. It is a very important point. Cations go to the cathode in galvanic cell and electrolytic cells, and anions go to the anode in both cases, galvanic cell and electrolytic cell. Another example. Okay, at this point we have finished this session. Thank you.